And I need to turn off some little pop-up thingy. Cool. Okay. Let's see if that worked. I bet it didn't. Okay. So fun with factoring. And we're actually going to spend 4 days at least in here talking about factoring. And the first thing that I'm going to say is if you already have skills and techniques for factoring from a previous life, don't unlearn things you already know how to do. I don't care how you get to the final result. So if you've got something that's already working for you, just keep doing it. I'm going to try to show multiple options for how we can work through factoring stuff. And hopefully we're going to find something that works for you. There are lots of different kinds of factoring that we end up doing throughout calculus and like other STEM classes and stuff. But one of our basic foundational things is just taking out something that all of our terms have in common. So for example, if I had something that looked like 12x plus 3x squared plus 6y cubed, and the instructions are to factor completely. I don't think there's an E there. Is anyone better at spelling than I am? Is it like no either? We don't know? Okay. Don't hold me to my spelling mistakes. Okay. The first thing that we're going to look for when we think about factoring is whether there is something that each of the terms have in common. And when I'm saying there's something they have in common, meaning that they each can be written in such a way that they have a common factor. So I'm going to do this extra step. I wouldn't actually write this out if I were just factoring the problem, but I just want to illustrate what I mean by having something in common. So if I look at that 12x, I can think about that. Sorry, give my pen a second to warm up. I can think about that as 3 times 4x. And I know that I've been mentioning that like having your multiplication and addition facts memorized is great for factoring. So I'm thinking about that 3x squared, and I'm going to think about that as 3 times x squared. And I'm going to think about the 6y cubed as saying 3 times 2y cubed. So when I look at each of the monomials here, when I look at each piece, and these are pieces that are separated by addition or subtraction, each of those pieces have a 3 in them. So we say that we factor out the 3, and then I just think about, well, what's left from each piece? So if I pull the 3 out, then what's left is 4x. And if I pull the 3 out, then what's left is x squared. And if I pull the 3 out, then what's left is 3y cubed. That would be factored completely. Question. I bet it would be 2y cubed if we pulled the 3 out. Good times. Now, I don't really actually write out that middle step. I'm doing that middle step in my head to find that 3 in there, but it's totally fine if it's helpful for you to write that out. So let's get a couple more examples here. Let's say we're going to have those same instructions that we're just trying to factor. And sometimes we might call this the greatest common factor. So we're going to factor out the greatest common factor. So I'm looking at 30xy squared minus 25x squared y. Well, when I look at this, the first thing is to kind of identify what are my terms. And the terms are always going to be what's separated by addition or subtraction. So I've got subtraction and I've got two terms. And now I'm thinking about what do they have in common? And I'm going to do the same thing that I did on the last one. And I'm actually going to like separate out the multiplication. Again, you don't have to do that each time, just kind of helping to see it. Well, when I look at both of these, that's an x, and that x squared is an x times another x. That's a y, and the y squared is a y times another y. So if I separate out, I can think about that 30 as 5 times 6, and I can think about that as saying x times y times y. This one, oh, and this is another just like, not so much notation, but handwriting point. I have written this as 5 times 6. Super important that that doesn't become a 56 when you're writing it down, right? So whatever you need to do to remember that there's multiplication there, you could put stuff in parentheses next to each other just to make sure that you're remembering that it's multiplication. Over here, that 25, I'm going to have 5 times 5. My x squared would be an x times a y. So I'm kind of dissecting that normally in my head. I'm thinking about how can I rewrite that as smaller multiplication parts so that I can identify what they have, what they both have. So they both have a 5, and they both have one x, and they both have one y. So I'm going to pull all those things out in front, the 5xy, and then I'll just look for each term, what did I not pull out yet? So from here, I'm left with a 6 and a y. And over here, I'm left with a 5, an x, and a y. Now I know it looks a little bit funny spaced out like this. Personally, I think gravity really helps math. I like things to be lined up under each other so that the math just kind of falls out as it moves down the page. So when I line this up, looks like I made a mistake. How's that? Does that look better? Okay. When I'm factoring like this, when I'm pulling something out, I like to not start the problem all the way to the left of my page because I like to leave space for this piece that I'm going to pull out in front. I know that that's like a really small thing, but if you can keep things organized on your paper, a lot of times it's easier to keep track like logically of the flow. Gonna give you all one to try. I don't know how messy we want to make it. How messy should I make it? Scale of 1 to 10. How messy are we getting? 10 being crazy messy. If you're on Zoom, give me a number. Crazy messy? Okay, I got some 10s, I got some 7s. Okay. Here we go. It's not going to be dreadful. But how about, so we're going to factor out the greatest common factor. I'm going to be lazy and abbreviate that GCF for greatest common factor. I'll put it up here. greatest common factor. Okay, let's go with 18 y cubed a squared plus 48 y squared a squared plus 28 a cubed. It's not crazy. But it is going to require us knowing some multiplication facts. So give that one a shot. And if you're on Zoom, when you figure out what you think the greatest common factor is, go ahead and pop that in the chat. What did you get for that greatest common factor? I only had one great person on Zoom. I didn't answer. How about the number part? Like what, so, yeah, what's in common number wise? Yeah, so for sure, we're gonna have some A's in common. How many A's do they all have in common? Totally. So I've got 2 A's in common for each term, but there is at least one number that I can pull out also. Because 18, 48, and 28 are all divisible by 2. So even if it's not a big number to pull out, I know that I can pull out 2 from each of them. So I'm looking at pulling out a 2a squared. And I'm not going to write out that intermediate step, but I'll give everybody like 30 seconds to finish it off in case you weren't sure about the greatest common factor. Oh yeah, so that's a really good point. So with all these numbers, the 18, the 48, and the 28, one way to find that greatest common factor is a technique from, gosh, like chapter 1, where we were doing the prime factorization stuff. So if you break them down to all of their smallest components, that's where you can really see what they have in common. So if I take the 18, if you saw that as 3 times 6, well, then we can break that 6 down further as 3 times 3. Sorry, how about 3 times 2? It's like, I can't even blame it on being a Monday. It's not even a Monday. But 18 is 3 times 3 times 2. And then 48, if I did the same thing and I was like, oh, well, 48 is 6 times 8. But then that 6 I could break down further as 3 times 2. And the 8 could become 4 times 2. But the 4 could become a 2 times 2. So overall, sorry, I'm going off the page here. Overall, that 48 would be 3 times 2 times 2 times 2 times 2. And then 28, 4 times 7, only thing I can do with that is change the 4 to be a 2 times 2. That's a whole lot of work. That's work that you don't have time for in pre-calc or calculus. That's work that really you probably want to be able to look at the 18, 48, and 28. This is not what I'm doing in my head. Like, this is, if the numbers are huge and I really can't figure it out, this is a method that will always work. What I'm actually doing in my head is just running through all the sets of factors. So what I'm thinking is I'm like, okay, what are the different ways I can write 18? I can write it as 6 times 3. I can write it as 9 times 2. Like, genuinely, that's what I'm doing in my head. I'm thinking about that 48 and I'm like, oh, well, that's 6 times 8. That's 4 times 12. That's 2 times 24. 28, all I got is 4 times 7. And then I'm like, oh, wait, but I guess I could also write that as 2 times 14. This is what I'm doing in my head. I'm not doing prime factorization. Yeah.
So basically, you just have to get like a number right now, but a number, I guess you can do that, divide into all of them, and then just find something. You know what I'm saying?
Perfect. I do know what you're saying.
Yeah.
I do know what you're saying. So yeah, we're looking for a number that divides into all of them. And then once you figure out what the number is, then you can like pick up what the other factor is for sure. You can do this when you're really stuck. And like, if I encountered something like, I don't know, 135, I'm probably going to have to go with prime factorization because I don't know what multiplies to be 135. But 18, 48, and 28, those are kind of facts that are small enough that we should be able to run through what the possible factors are. Yeah. Okay, back to actually finishing off the problem. If I pull out a 2a squared from here, I'm going to have a 9. I'll still have the y cubed, but all my a squareds have popped out. I'm going to have a 24 and a y squared, and all of those a squareds have popped out. And then over here, 28, so I'm going to have 14. 2 of my a's have come out, but I'm going to have 1 remaining. So my page got a little bit messy, but I'll just kind of block this stuff off. Good times? Question.
So the reason you didn't cancel out the y space in the first two is because the 28a to the power of 3 doesn't have an answer. So in order to cancel
Correct.
it out, they all have to share it.
Yes. So they all would have to have shared y's in order to pull it out. Yeah, same question came up in the chat on Zoom. Why couldn't we pull the y out? So if I'm trying to pull something out of all 3 terms, it has to be present in all 3 terms. Otherwise, we don't consider it factoring. So let me rewrite this problem and show something that is algebraically equivalent, but we wouldn't call it factored. Okay, someone might have to read. I'm just trying to write down the question we just did. Can someone read it to me? So I don't have to flip my paper. Yep.
Plus 48 y squared.
So, things that are algebraically equivalent, but not considered factored. This is the same as I could just look at two of the factors. Sorry, I could just look at two of the terms and think about factoring. So if I were to only look at these two terms, those two terms have a 2 and a y squared and an a squared in common. And then I'd be left with 9y. Having trouble mathing this morning. Happens to the best of us, right? 9y plus 24. But then I couldn't take that out of the 28a cubed. So it would just be hanging off the back. Well, that's not considered factored because the whole idea with factoring is that I'm going to end up with pieces that are multiplied together, that we won't have sort of these dangling addition and subtraction parts. This is actually also equivalent to if I had grouped the second pieces together instead. So if I had if I left the 18y cubed a squared alone, and I looked at the second two pieces, well, those second two pieces actually have a 4a squared in common. And then I could have a 12y squared plus 7a. But again, I would have this dangling part that's being added to things that are multiplied. So neither of these are factored. Good times? Sure. So how about one more example like this, and then we'll move on to a slightly different flavor of factoring. So let me go 12x squared y cubed minus 72 x to the 5th y cubed minus 36 x to the 4th y to the 4th. So the first thing that I want you to look for is what is that greatest common factor that we're going to try to pull out. So I've got three pieces that are separated by addition or subtraction. What is that greatest common factor? Any volunteers for what our greatest common factor is? Okay, so I've got to guess in terms of the number. And I will say that anyone that has had to measure, cut, or purchase lumber is at an advantage on this problem. I have done a lot of that over the years because 72 is a 6-foot board. 72 inches is a 6-foot board. So honestly, that is why I know that 72 is divisible by 12, not because I know it as a multiplication fact, but because I've purchased and cut a lot of lumber. So if you didn't see that, if you didn't see that the 12 was the greatest common factor in terms of those numbers, that's okay. We can do this in 2 steps. So if you didn't see it was a 12, let's pretend we actually thought that it was 6. So if I thought it was 6, and then I looked at my X's and Y's and I said, okay, that's 2 X's. Basically, I'm going to look at all of the X terms, and whichever one has the smallest exponent, that's the one I got to pull out. So I'm looking at an X squared. Then I'm going to look at my Y terms. Smallest exponent on Y's are Y cubed, so that's the most I can pull out. So if I did that and I pulled all that stuff out, then here I'd end up with 2. And then I would still have to know that 6 times 12 was 72. But let's say I knew that. So I've got the 12. I've pulled out 2 of the X's. So I'm going to be left with 3 in here. I've pulled all the Y's out. I've pulled out 2 of the 4 X's. So I'm going to have 6x squared. I've pulled out 3 of the Y's. So I'd have a Y. But then I could look at that and say, oh, wait, let me just do a quick check. Did I really get everything? I didn't, because I can still grab a 2 from 2, 12, and 6. And it's okay if you ended up doing it in 2 steps. So if I pull another 2 out so that I have 2 times 6 times x squared y cubed, so then we'd have y minus 6x cubed minus 3x squared y. Totally fine. If the problem says to factor completely, then it is important that if we see something else that we could have pulled out, that we take the time to pull that extra thing out. My next example is going to get slightly more complicated, so trying to make sure that people are caught up and we've got any questions answered. Yeah.
So the greatest common factors is the biggest.
Yep. Yeah, it's like the most that I can pull out. Yeah. Not seeing questions in the chat or in the room. So I mentioned that we're going to do lots of different kinds of factoring because there are lots of different kinds of factoring that we're going to encounter in pre-calc and calculus. So one of the types of factoring is referred to as factor by grouping. And when we talk about factoring by grouping, we're going to use that idea of pulling out the greatest common factor, but we're going to do it twice. So I'm going to start in a state where I've kind of like already done step 1, and then we'll do another example. So if I started with something that kind of looked like it was already factored, maybe I've got x squared times, in parentheses, x plus 3 minus y x times x plus 3. So the idea, or at least the phrase factor by grouping, I've kind of already grouped things together in this example, and we'll do one where we have extra steps to it. But if I have to factor this, I identify the pieces by what's separated by a plus or a minus sign. So when I look at each of these pieces, the thing that they have in common is that x plus 3 in parentheses. So it's not so much that I'm pulling out like an individual x or an individual 3. I'm actually going to grab that entire piece in parentheses. I'm going to pull out the x plus 3. Now these happen to have something else in common, because I've got an x squared and a y times x. So I can also pull an x out. And when I do that, what's left from the first piece is x. And what's left from the second piece is just the y. Now I know it looks kind of funny on the paper. So I kind of regroup that together as x times x plus 3, x minus y. And that would be my final most factored form. Usually our factor by grouping problems do not start out already with these little groups together. So let's take a look at what happens when they're not nicely already started for us. I'm gonna flip the page. Good. So I'm looking at 6x squared plus 9x plus 4x plus 6. Okay, you might look at that, and if I'm supposed to factor this, you might look at that and say, oh wait, the 9x and the 4x, we could combine like terms. You absolutely could, but our instructions are to factor, so I'm not really trying to combine like terms here. And specifically, I'm going to do this as a factor by grouping. So I'm going to look at this, and I'm going to treat it, instead of 4 separate things, as 2 groups. And in each group, I'm looking for the greatest common factor that I can pull out of them. The objective is really, in the end, to find a factor that each group has in common. But I'm going to start by pulling out the greatest common factor and just hope that that works. So if I grab the greatest common factor here, 6 and 9, you can divide both of those by 3. So I would pull out 3x. And then what I'm left with is 2x plus 3. Well, when I look at my second group, 4x and 6, the only thing they have in common is 2. And when I pull that 2 out, I end up with 2x plus 3. So the idea behind factoring by grouping is that hopefully after you've pulled out that greatest common factor, then you end up with a common factor between the 2 groups. So we factor in 2 steps. We group them, we factor from the groups, and then we factor the overall. I did not leave myself enough space on the paper here. So I was saying, when I do factoring problems, I really do try to center them on the page. So I'm going to unconventionally factor my 2x plus 3 on the right-hand side, because I don't have space to squeeze it in over here, but it's okay. So if I pull out the 2x plus 3, then from this first term, I've got 3x, and from the second term, I have 2. 3x plus 2 times 2x plus 3 would be my overall answer. I will tell you that I really honestly used to hate factoring by grouping. And I was like, this is dumb. Over the years, I have found that I'm going to go with on average, about 25% of students, this works better for them in their brain. And so if you are one of those people that like sees patterns, I am not one of those people. But I like to show it now because of how much more successful some students are factoring this way than any other factoring method. If it's not working for you, that's okay. Just hang in there, practice it with me for a minute. Yeah. Oh, excellent question. It does not matter which order you put the parentheses because it's multiplication, right? So 5 times 6 means the same thing as 6 times 5. So especially if you're like checking your work in the back of the book or something, it's totally fine if you had the factors switched. Mm-hmm. So we got time for another one. We're also going to factor this by grouping. How about 6x cubed? I know I'm not leaving myself enough space. Before I get myself into trouble, I'm going to move it over. Okay. 6x cubed minus 4x squared plus 15x minus 10. Oh, I should also point out that this is a cubic. We call it a cubic because the largest power of x is to the third. There aren't a lot of techniques for factoring cubics. Factoring by grouping is one of the only techniques that we have. There are a couple in others in some very specific situations. But if I'm going to factor this by grouping, I'm going to treat my two groups and look for the greatest common factor in each of them. I'm going to let you all try this one on your own. Yep. Oh, did you get the first part of the factoring? Yes. Okay. So now I'm trying to figure that out. Yeah. Is that what you got two? 2x squared plus 5 was the other like, factor thingy on this one. All I did in that very, very last step was like to make the parentheses nicer. Yeah. Okay, so getting some answers in the chat. Answers in the chat look good so far. So if I look at this first piece, I know that I can pull out a 2 and an x squared. which would give me 3x minus 2. And the second piece, we can pull out a 5, which would give me 3x minus 2. And the hope every time we're doing the factoring by grouping is that when we pull out that greatest common factor, what's left matches between the two groups. Since it matches, I'm going to repeat the whole process for the bigger thing. And if I pull out the 3x minus 2, then I am left with the 2x squared plus the 5. Now I just kind of rewrite it at the end so it's a little prettier. 3x minus 2 times 2x squared plus 5. By the way, if you get to the end and you're like, but am I right? If you want to check your work, you always can multiply it back out and make sure you get the same thing that we started with. So I know that sometimes it's nice to have a method to check your work. So anytime you're factoring, we can check the answer by multiplying it back out. And I'm going to write this as optional because if I don't, I know that some of you will do it every single time. Have some faith. You've got some skills. But yeah, let's check it. So we can FOIL it out. We can use the box method. We can use the rainbow method. Whatever you want to do, multiply that back out. I'm going to go for a box, but you don't have to watch me do it. You can do it on your own paper. I got nervous. I thought it didn't work. And then I realized I wrote the thing wrong. Mine matched. So I think we're good. Dun, dun, dun. Flip this over. We have 4 minutes. Let us practice just one more here. Question before we do.
Oh, wait, no.
Yeah,
Because I think, because I need to rearrange the order. Right?
correct.
That's what
Yeah.
it's like, you know, you just get it like that, but then.
Yeah, so when you multiply it out, like you can rearrange the order between the addition and subtraction stuff for sure. Yeah. Okay, I don't already have an example that looks like this, so I gotta like make one up in my head. It's hard for me to make these up in my head. So let's go with two x squared plus 4x plus plus x plus 2. I think I got this. we're gonna do this together because this is actually one of the things that I always struggled with factoring by grouping, because something weird is about to happen. Okay, we're gonna factor this by grouping. So I'm gonna look at my two groups. And I'm not gonna lie, if I look at my second group, there is nothing I can pull out. Also, Amber's on top of the factoring by grouping. Nicely done. So I'm gonna look at the first group and I'm gonna factor out the only thing I've got, a 2x. And if I pull the 2x out, I'm left with x plus 2. Conveniently, that's also what I already have over here. So what I'm gonna do is I'm not really gonna factor something out. I'm just gonna write it as +1 times x plus 2. Because there kind of wasn't anything to factor out. But that's gonna let me do that second grouping step to say both of these have an x plus 2, which means I've got a 2x and a +1. And forever, these have been the ones that were hardest for me to like see mentally. And I think this was always my block about factoring by grouping. Now, similarly, if this had been like a -x -2, the same kind of thing would have happened, but the number that I would pull out was a -1 to pull those negatives out. So we're gonna spend way more time factoring. This was just getting started. We are going to be factoring trinomials. So if you want to read ahead and look at the section in the book on factoring trinomials, great. I'm going to show at least a couple different methods to do it. You, at the end, are going to be able to do whatever works for you. Good times. It is Wednesday. I don't have office hours on Wednesday, but I do have office hours tomorrow. If anyone wants to come hang out with me over on the second floor of the Memorial Union in the Chicanx Latinx Center, I will be over there from about 12:15 to 1:30 tomorrow, so Thursday. You are very welcome.